when we do this, so 2 times 2 is
4.
4 plus 3 is
7.
4 times 7 is
28.
28 minus 5 is
23.
so my final answer will be 23. Okay, that is what you're doing when you're using PEMDAS. You're evaluating with PEMDAS. I took the 2 and I plugged it in for X. Okay, so I'm going to do the same thing with 5. I'm going to evaluate. So 5 times 2 is
10.
10 plus 3 is
13.
13 times 4 is
52.
52 minus 5 is, and so my answer would be 47. That again is evaluating. Okay? Well, notice here. Do I know what I plugged in for X? No, but I do know what Y is, right? So I work it backwards. So these are our steps that we're going to have to work it backwards. So the first, instead of subtract 5, I'm going to, instead of multiply by 4, I'm going to, instead of add 3, I'm going to,
Subtract 3.
and instead of multiply by 2, I'm going to, so I'm going to start at 99 still, right? I'm going to add 5, and that gives me, and at this step I'm going to divide by 4, and I get 26.
Yeah.
And then I subtract 3 and I get,
23.
and then I divide by 2 and I get 11.5. That is what you're doing when you're working backwards. Just to make sure you understand that, this is what you're doing. So in your mind, that's what you should be thinking. But do you want to list out the steps every time? No, you should be at the point where you're doing this. If I'm working backwards, that means I know what Y is. So if I know Y is 99, to get X, I'm going to start working backwards, right? I'm going to add 5. Isn't that what we did? Okay? Then it said to divide by 4. Isn't that what we did? Then we said to subtract 3. Is that what we did? And then we said to divide by 2. And isn't that what we did?
Yes.
And did we not receive the same step, the same answer?
Yes.
So what is the problem with this, guys? What is your biggest struggle when you have to do this? What is your problem with working backwards? You're saying yes, yes, yes while I'm up here. But then when you're alone, no, no. That's all you do. Guess what? I'm not going to say anything. You're going to do number 2. All right, so do number 2.
What's the opposite of square root?
Square root. Can you square something? The opposite is square root. Where is it?
To that place.
It's
It's like a man-made place thing. Did you hear him talking about it? Man-made.
no, Bailey wasn't there on the first page. It's called Valente Beach. It's a man-made beach in the middle of Texas.
And there's like slides and stuff.
It's like a beach mixed with little girls out of music park. Did you sign up for it? You paid your dues, AJ. Maybe you should sign up to go. On the board.
Oh my gosh. We just went over this.
That's the steps. Yeah, we just wrote down our steps.
So emotional.
So instead of squaring it, what are we doing?
Take the square root.
So I'm going to take a series of
The square root. All right, so let's evaluate. So evaluate means I'm going to plug in. And this tells me to add 3, square it, times 4, subtract 5, right? So I'm going to add 3 and I get 5. 5 squared is 25. 25 times 4 is 100. 100 minus 5 is 95. Over here. 5 add 3. 8. 8 squared is
64.
64 times 4 is
256.
256 minus 5 is
259. I'm 51.
Alright, so we can evaluate. Now we're going to solve backwards. So instead of subtracting 5, I'm going to... Oh, please write. And then I'm going to divide by 4. Yikes. Sorry, guys. My board and I are not being friends today for some very strange reason. I think my battery may be going dead in my pen. And then square root. And then alright, so I'm gonna start off with 191. And I'm and then I get 196. And then I divide it by and I get
49.
and then the square root of 49 is
7.
and then I subtract 3 and I get okay, so you guys, y'all understand it with numbers. Okay, because we're going to now use variables. The reason why we use a variable is because there's an infinite amount of numbers, and we want to be able to do this with an infinite amount of numbers quickly and easily. Okay? So now we're going to go on to the variable part. So this is our function. This function tells me to multiply by 3, subtract 7, divide by 4, add 11. Do we all agree with that?
Yes.
Is that what this function tells me to do?
Yes.
So to any number, I'm going to multiply by 3, subtract 7, divide by 4, add 11. This is the function. So when I work backwards, what is that called?
Inverse.
Inverse. It's called the inverse of the function. So when we start to work backwards, we use the inverse. So using the inverse and working backwards. Instead of adding 11, I am
Subtracting 11.
and instead of dividing by 4, I am
Multiplying.
multiplying by 4. Instead of subtracting 7, I am. And instead of multiplying by 3, I am. Okay? So that's me working backwards. But I want to be able to do this to any number. So to represent any number, I start with x. So to this x, what am I going to do to it? Subtract 11. And then after I subtract 11, what am I going to do to it? So I'm going to multiply by 4. Then after I multiply by 4, what am I going to do to it? I'm going to add 7. And then after I add 7, I'm going to do what?
Divided by 3.
And guess what? You just wrote the inverse. Okay? This is what we were starting on Friday, but you guys are like, what is she doing? And that's when I realized that your algebra is not your friend. Okay? On Friday, I tried to show you without words. I just tried to show you algebraically. So on Friday, I'm going to go back. So on Friday, we did it this way, right? We talked about switching x and y, and then solving for y. So, how do we do this? Well, I need to move 11. So, how do I move a positive 11? So, I subtract 11. Now I have a 4. How do I move a dividing 4? Multiply by 4. Alright, so now I have a negative 7. How do I move a negative 7? Add 7. Now I'm multiplying my 3. What's the opposite of multiplying my 3?
Divide by 3.
Did we not get the same answer? So what was the struggle on Friday?
I don't remember Friday.
It's just that when we're on our own, we like.
Is that when we took?
When you're not
What are you talking about? What's Friday? Yes, that was easy.
Okay, but do we see it now?
yeah.
Do we see how now the words go with the actions? Yes? Alright, so on the back of your paper, I want you to split it into 4s.
I didn't wrote.
Either way. Hi, Shaterica. It doesn't matter. It doesn't need a whole lot. Well, if you write big, you do. Alright, so this is the back of my paper, and I split it into 4s. It is in 4 sections.
Never mind.
Is it not?
That's beautiful.
Alright, so this is going to be 4a, and 4a says f of 13. So I did not leave you enough room on the front. This is going to be 4b, and 4b says inverse with 13. This is going to be 4c, and 4c says inverse composed of f of 13. And then this is 4D, and it says f composed of the inverse at 13. These are on the front at the bottom. You may have enough room if you want to do it on the front, but I wasn't sure if you did, and I just wanted to make sure you could see everything. So if you feel like you have enough room, you can do it on the front. If you feel like you don't, you may do it on the back. Alright, so f of 13. F of 13 tells me I'm going to do what?
You don't substitute
Plug that in as X.
Plug it in x into what function?
X.
Alright, so plug into f of x, right? Alright, and f of x is what?
It's
What is
3x minus 7
3x minus 7
plus 11.
divided by 4 plus 11. So wherever x is, I'm going to plug in
13.
13. So f of 13 is 3 times 13 minus 7 over 4
Plus 11.
plus 11. It reduces to 39 minus 7.
32.
8.
32 over 4 minus 7,
19.
which reduces to,
Wait, hold on.
sorry, I wrote that
Wait a
backwards.
second. Oh, yeah, you did.
Lo siento, don't look. My eraser's too small. Still don't look. And what is it? 19. Do we understand this?
Yes.
Did anyone get confused on this?
No.
Alright, so 4B. Is it any different than 4A? Well, the only thing that's different is I'm plugging into the what?
The inverse.
Inverse. So I'm going to plug into inverse of x. And what is the inverse of x?
4
4, 13, minus 11,
x minus 11
plus 7, plus 3.
plus 7 divided by 3.
Alright, so now I'm going to plug in 13, right? So I get 4 times 13 minus 11 plus 7 over 3. I think the last one's supposed to be 25.
Yeah.
I will fix that momentarily. So I have 4 times 2 is? 13 minus 11 is 2. So 4 times 2 is? 8 plus 7 over 3 becomes 15 over 3, which equals? So my answer is? Can we evaluate? Is there anyone who's uncomfortable with evaluating and you're paying attention and that's why you're uncomfortable? Evaluating is just plugging into. Good?
Yeah.
All right. So now we're going to compose. All right. So this is composing. But all you're doing is evaluating twice. So it's the same thing except I'm just evaluating twice. So my first time I evaluate is on the inside. So f of 13, well, conveniently, do we know what f of 13 is?
Yes.
What is it?
19.
Okay, so we know f of 13 is 19, right? All right, so we did the inside. Now we focus on the outside. So our inside is substituted for 19. This is substitution. If they're equal to each other, you can substitute them in, right?
Yes.
All right, so inverse of 19. So I'm going to take 19 and plug it into the inverse. So 4 times 19 minus 11 plus 7 divided by 3. Well, what's 19 minus 11?
8.
4 times 8 is?
32.
What is that?
39. 39 over 3, which equals 13.
That's what I'm saying.
Was that hard?
It's a bit faster.
Competition.
What are you saying now?
I have no clue what he is trying to say. But, oh, okay. Where's the struggle at?
Oh, but at the beginning, before you read everything down,
This part?
So basically, you have to get 4A done in order to do 4C.
Yes. Well, basically, you have to get the inside done in order to do the outside. Okay? So you have to do the inside of the composition before you can do the outside. That is why you're evaluating twice. Do y'all see that?
Yes.
So all you're doing is evaluating twice.
So it goes from the inside to the outside.
Inside to the outside. Alright? Alright, I wrote 13 and it should be 25. Correct?
Yes.
Alright, you're going to do this one.
I wasn't ready.
Alright, so you're doing the inside. It says 25 on your note. And I wrote 13. Alright, do it.
Do what? Oh.
D. 4D.
What if we gave it?
Wait, we have to change it to
I did. So you need to find it first, don't you?
Yeah.
Do we know what the inverse of 25 is? No, but we need to find it.
for some reason it was saying that same.
No, I just told you it's 25. I told you 13.
B is
5.
but she read it wrong.
Oh, so it was 20.
Huh?
Is this homework?
There you go. That. I know. I can't take medicine at school. It makes me drowsy.
Are we supposed to get a decimal?
Yes, you need to. Which one are you plugging 25 into?
The X, right?
So we don't know.
But which function? Are you plugging into the original or the inverse?
The inverse.
There you go.
Oh, that's what I'm missing.
Remember, you do the inside first.
Okay.
Yes.
It's very intense.
Brand out of proof.
I said that thing.
Why didn't you say that? Say something.
I said that like 2 weeks ago.
Like the first day I saw him.
All right. How many people got 25?
Oh gosh.
Okay, if you got 21, that means you only did half of the problem. Okay? So composing means that you're evaluating how many times? Twice. You have to evaluate twice. So I evaluate the inside first, right? The answer I got from my inside, I'm going to use it to, I'm going to substitute it into my inside. And then I evaluate the second time. So this time I'm going to the original function, which is 3 times 21, Megan, minus 7 divided by 4 plus 11. Yes, Dulce. All right, Dulce, that's a very good question. Is the answer going to be always what they give it to you? That's what I wanted you to realize. What did you get here?
13.
What did we get here? Okay, the reason why is because the inverse is a function. If the inverse is a function, that means that these two statements will be true. They will always give me the same thing. This is called the inverse test. And this is how you test algebraically whether your inverse is a function. If my inverse is a function, then this will be the same. After my second evaluation, my answers will be the same. So this just proved that the inverse function is a actual function. That means it passes the vertical line test. And we did it without a graph. Yes?
So, will their equations
They are not?
the same?
Yes. And what time we got here? What time we get out here? 50? Okay, so we only have one. We probably can only do one of your homework problems. Yes, we are. All right. So on your homework, huh? It's a grade.
What you mean? I forced
Alright, so on your back of your paper, it shows you what you're doing for your assignment. So for 1 through 6, this is what you need to do. First, you need to find the inverse. Okay? Once you find the inverse, you need to test and see if the inverse is a function or not. The way you test to see if an inverse is a function or not, AJ, is by plugging the original function into the inverse, and by plugging the inverse into the original function. So we're going to do number 1 together. If you write large, you're not going to have enough room to do this on your homework. So if you write large, you will need to use a separate piece of paper. Alright, so here, this is my original function. So to find the inverse, I know that instead of adding 12, I'm going to, and instead of multiply by negative 4, I'm going to divide. So I know that my inverse is going to have to be x minus 12 divided by negative 4. That's my inverse, right? I do exactly the opposite of what is said here, and that's what we went over on our notes. You're doing exactly the opposite of what is said here. So I have my inverse. Now I need to test my inverse. To test your inverse, you do f of, and you're going to substitute this in for x, because I do the inside, right? And if it's an inverse, I should end with x, because what am I starting off with? X. Okay? So I'm going to plug it in. So I have y equals negative 4 times x minus 12 over negative 4 plus 12. So I literally substituted this into x. That's what composition is. Okay? If you are not comfortable doing it with an equation, you may choose a number and plug in a number. The only problem is sometimes the number doesn't give you the answer all the time. Alright, so what happens here? Negative 4 and negative 4 is going to do what? So I'm left with y equals x minus 12 plus 12. And what happens? What happens here?
They cancel out.
The 12 cancels out. So I'm left with y equals x. So far, is it a function? Yes, because it passed the first round of testing. So that's the first round. The second round is when you do the opposite. The inverse is now going to be substituted in with the original. And my answer still should be x. So this time, I'm using this, and I'm plugging in the inverse. At this point for me, I strongly suggest to simplify your inverse. And by simplify, this takes you back to Algebra 1. That is the simplified version of your inverse. Okay? The reason why is you divide each term by negative 4. Okay? Do y'all remember this from Algebra 1? This is a 4 and a 3. Okay? If not, you're going to have to, you can work with this, but in this case, it would be better to simplify it. If you do not remember how to simplify it, then just work with this one. And we'll work with this one for now. So, practice. Separate piece of paper if you write large. And you need to end up with the inverse and tell me whether it's a function or not. I saw something also like you have to let you get me take over that. How can I do it today? Stop, Ricky.
Hey, you gotta show me this a bunch though.